Chapter 2, Multiply Whole Numbers, Check My Progress Study Guide. So this will be for your first quiz in Chapter 2, Lessons 1 through 5. So let's take a look at our first question. Question number 1, and let me pick a color here. We're going to go with red. The question is 10 to the second power. This tells us how many times we're going to write 10 as a factor. So this is the power of 2. So that means we're going to write 10 2 times as a factor. 10 times 10, which equals 100. So the answer to question number 1 is 100. Question number 2 is 14 to the third power. So we have 14 to the third power. I'm going to do my math on the side. 14 times 14. 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus 1 is 5. I'm done multiplying by the 4. I add a 0 because this 1 is in the tens place. 1 times 4 is 4. 1 times 1 is 1. Now I can add. 6 plus 0 is 6. 5 plus 4 is 9. Nothing plus 1 is 1. Now we have to multiply it 3 times. So that would be 14 times 14 times 14. So we multiplied it twice, 14 times 14, but now I need to multiply it one more time. So we have 196 times 14. 4 times 6 is 24. 4 times 9 is 36. Plus 2, 36, 37, 38. Carry the 3. 4 times 1 is 4, plus 3 is 7. Okay, so I'm done multiplying by the 4. I'm going to add a 0 as a placeholder. 1 times 6 is 6. 1 times 9 is 9. 1 times 1 is 1. Now we add. 4 plus 0 is 4. 8 plus 6 is 14, carry the 1. 9 plus 1 is 10, plus 7 is 17, carry the 1. 1 plus 1 is 2. And our answer is 2,744. Question number 3 is 7 to the second power, which equals 7 times 7. Now, your brain probably will go quickly and you'll think to yourself the answer is 14. This is why you need to slow down and make sure that you write the problem out because it's actually 49. Okay, sometimes when we do math really quickly, we skip ahead and our brain does stuff really fast and we forget. It's not 7 times 2, it's 7 times 7, and that equals 49. Next page, next set of problems, here we go. All right, find the prime factorization for each number using exponents. Now, you may make a tree that looks different from the tree that I make, but your factor string should look the same when it's all said and done. All right, so I'm going to start with 50, and I'm going to break that up into 5 times 10. Now, 5 is a prime number, so I'm going to circle it. And then I'm going to break 10 up into 2 times 5. So 50 equals 2 times 5 times 5. And that would actually equal 2 times 5 to the second power. So our answer is 2 times 5 to the second power. Question number 5, same thing. Find the prime factorization of each number using exponents. So we have 560, and again, you might have a different tree, but your final answer should be the same as my final answer. I'm going to do 56 times 10. Then I'm going to break 10 down into 2 times 5. These are 2 and 5 are prime numbers, so I'm going to circle them. They're the dead ends. All right, and then here, 56 would be 7 times 8. 7 is a prime number. 8 is 2 times 4. 2 is a prime number. And 4 is 2 times 2. And they are prime numbers. So 560 equals, I have 1, 2, 3, 4. 1, 2, 3, 4 sets of 2's times 5 times 7. Now, I do like to write my factors in order from least to greatest, and this would be 2 to the 4th power times 5 times 7. Okay, so that's 2 to the 4th power times 5 times 7. I am using the multiplication symbol, but just remember a multiplication symbol could be an X, it could also be a circle, and on a computer sometimes we have an asterisk. So you can use these symbols you will see as all multiplication. Find each product mentally. Now, obviously you can't see what's going on in my brain, so I will talk out what we're doing here. So for number 6, we have 60 times 500. So in my head, I'm multiplying 6 times 5, and I'm getting 30. Then because these both factors end in zeros, I can just count them, 1, 2, 3, and add them to my product. So I should have 30,000 as my answer. Question number 7. 240 times 10 to the 2nd power. In my head, I'm changing 10 to the 2nd power to 10 times 10, which I know is 100. So in my head, I know this is 100, and I know 100 has 2 zeros, so I'm just going to add the 2 zeros to 240. So 240, and I'm going to add 2 zeros to that. And then I have a comma here. So my answer is 24,000. All right, question number 8. We have 96 times 10 to the 3rd power. In my head, I know that 10 to the 3rd power has 3 zeros. It's a 1, with 3 zeros. And I can just add those 3 zeros to my number 96. 96, 1, 2, 3. So my answer is 96 with 3 zeros, which means that's 96,000. All right, now hold this thought because I do want to tell you when you get a little bit older now, and every teacher teaches things differently. So I do want to, just in case your teachers taught you it a different way, I do want to at least address this because this is actually what's happening here. We don't add, I should say, I don't like to say that we add zeros. So let's go back to number 7. We have 240 times 10 to the second power. 10 to the second power tells me that I'm going to move the decimal point 2 times to the right. All right. I'm sorry, I didn't draw that really well. Okay, 2 times to the right, the decimal point. So where is the decimal point in a whole number? It's at the very end, just like in a sentence. The period comes at the end of a sentence. It's right here. So if I move the decimal point 2 times to the right, 1, 2, I will get 24,000. Okay. So problem number 8, we have 96 times 10 to the third power. And when you multiply a problem by a power of 10, this is telling me to move, this is a positive power. I am moving it 3, the decimal point, gosh, I'm so bad at this arrow drawing, 3 spaces to the right. So you will have 96, it's a whole number. That means the decimal point is at the very end of the number, and you move it 3 spaces to the right. And that will give you 96,000. Now this is the way I do it. I move the decimal point. Maybe your teacher taught you to add zeros, but either way, it's okay. Question number 9. Mr. Gabriel bought 10 to the second power packages of pens. Each package contained 15 pens. How many pens did he buy? All right, so he bought 10 to the second power packages of pens. So that would be 10 times 10, which would equal 100 packages. And if there's 15 pens in each package, that would be 15, I'm going to do it over here, 100 times 15. And you should be able to do that mentally. That would be 1,500, which is some adults say that, but it's actually 1,500. You would have 1,500 pens. Now, some adults say 1,500. It's not really a place value. It's just kind of slang for math. All right, here we go. Andre is helping his father build a toy box for his little brother. The amount of space inside the toy box can be found by multiplying its width, length, and height. Write the amount of space using an exponent, then evaluate. So volume equals the width times, I'm going to use a dot here for multiplication, length times height. Now this is a square, and as we know, or a cube, and all the sides are the same length. So the volume is going to equal 3 feet times 3 feet times 3 feet. So the volume is going to equal 3 feet cubed. Okay, so the volume is going to equal 3 times 3 is 9, and 9 times 3 is 27 feet cubed. This brings us to the end, and I wish you good luck on your quiz.